Hello friends, in this video we shall be solving a problem on the board. The question says, why is the relative atomic mass of chlorine 35.5? That is to say, why is the relative atomic mass of the element chlorine not a whole number? Now, this brings us to the topic isotopic. Isotopic has to do with the existence of an atom having the same atomic number, but the mass numbers are different. For example, I have three elements or three atoms, and all atoms having atomic numbers x, but the mass numbers are different. So, for example, this is A, this is B, and this is C. The atomic numbers are the same, but they have different mass number. As a matter of fact, because it's due to differences in the number of neutrons. That is to say, the neutron number for each of the atoms they differ, they are not the same. Now, the reason why we consider chlorine to be having 35.5 is this. Chlorine exists in two isotopic forms. The first one, we have chlorine 35. The second one is chlorine 37. Both are having atomic number of 17. And now, the reason we are having 35.5 is very simple. I'm going to be analyzing this in two ways. The first one is for the chlorine 35, we simply have more of the 35 relative atomic mass chlorine compared to the 37, which is to say, for 35, we have about three times of chlorine 35 and just one portion of chlorine 37. That is to say, if we consider the atom, our atom is having the center, the nucleus, and then the protons and the neutrons, they are surrounded by it. So let's assume this is chlorine 35. We have three portions of it. For chlorine 35, protons and neutrons are the center of the nucleus. We have three portions of it, and just a portion of chlorine 37. Remember, chlorine 37 is having more neutron number, having more neutrons. As a matter of fact, chlorine 35 is having about 18 neutrons and 17 protons. The same for this, we have 18 neutrons and 17 protons, 18 neutrons and then 17 protons. While for chlorine 37, we have 20 neutrons and 17 protons. Now, the weighted average of all the atoms, all the isotopic forms of the atom will add together to give us 35.5. How is this done? Now, we have four parts here. Method 1. This is 35. So we have, for the first method, 35, 35, 35, 37. So when I sum them together, I have 35, 35, 35, and 37. Summing these together, it is 15, 5, 5, 5, this 15, 15 plus 7. That is 22. So we have 2, carry 2. This 3 gives us a 12. 12 plus 2 is 14. So we have 142. Now when I divide 142 by 4, right? Because I have 1, 2, 3, 4. 3 portions of the 35, 3 portions, and just 1 portion of 37. So 1, 2, 3, 4 divided by 4 simply gives us 35.5. That is what the reason why we have the ring 35.5, which is not a whole number. On the second note, Method 2, we are going to consider each of these parts to be single, meaning this is 25%, this is also 25%, this also is 25%, and this is 25%, making 100%. So that is to say, for chlorine 35, we have 25, 25, 25, which makes 75% of chlorine 35, then plus 25% of chlorine 37. So solving this using the method 2, we are going to be having 75%, if we have 3 of it, 75% of chlorine 35 plus 25% of chlorine 37. We are going to be solving this. This will give us 0.75 times 35 plus 0.25 times 37. Now when we multiply this, we are going to get 26.25 plus multiplying this gives us 9.25. At the end of the day, when we add both figures, we are going to arrive at 35.5. And see, we got the same value using either of the methods. This is the reason why chlorine is not having a whole number. That is to say, the relative atomic mass of chlorine is not a whole number. Different isotopes put together to form chlorine with atomic number 17 and mass number, which is the relative atomic mass 35.5.